signal for single sinusoidal modulating frequency for three cases. Number one, when m is equal to 0. Secondly, when m is less than 1 and greater than 0. And third case is when m is equal to 1. So we all know that modulating signal, the instantaneous value is equal to am sine omega mt. Omega m is 2 pi fm. Am is the maximum amplitude, fm is the frequency of the modulating signal, mt is your instantaneous voltage of the modulating signal. Similarly, the carrier ct is equal to ac sine omega t. AC is your maximum amplitude and fc is the frequency. M is the modulation index, is the ratio of AM to AC. FC is always greater than FM. So here it should be at least 10 times FM or it can go to 100 times FM. The equation for amplitude modulated signal is given here in the standard form. That's 1 plus M into MT into CT. So we will use the first case first. You will try with the case 1 where m is equal to 0, then we'll go for the case 2 and then for the case 3. I like to show you the picture of the sinusoidal wave, carrier and the modulated signal before going to the coding part. So the upper one is my modulating signal. I should be getting in this format, and then my carrier signal after that, and then is my last one is my amplitude modulated signal. So I can see the different kinds of waves in single slide, and we'll have this format by using the different types of codes by using MATLAB or Octave. So let's go to the coding part. I am using Octave Online. You can use MATLAB. Since I didn't have MATLAB on my laptop here, so I'm using the online platform. So let's start with the coding part with the first case when I have when I have my m is equal to 0. This is my case 1. So here my time is equal to 0, 0.001, 1. Yes, this means I'm going to plot the graph from 0 to 1 second with the intervals of 0.001 outputs. So I will have 1000 outputs between 0 to 1 seconds. It means that. So you can vary the 0.001 to 0.0001 or 0.01 depending how many intervals you want in your outputs. AM I'm taking as 0 because I'm taking for the case m is equal to 0. So AM has to be 0 here. AC didn't take any value around 6. FC is my carrier. I've taken 100. FM can take around 5 hertz. Has to be mentioned. It is the ratio of AM by AC. Instantaneous value of modulating signal is equal to peak value into sine of omega t, that is 2 pi fm t. I wish to plot this sine wave, so I'll use the subplot command. This will help me to plot this sine wave, the modulating signal, carrier, and amplitude in one slide. So I want it in the array form. So I like to have, it's like row, column, and the number where I'm having. So 4 rows are there, 1 column, and the first part is my modulating signal. That's why it is 4, 1, 1. 4 columns and 1 row. 4 rows and 1 column. This subplot command is used to plot different graphs in a single slide. Then I need a plot command to plot first x-axis, then y-axis. I need to mention the title for modulating signal. So you should write your name there, print your name and your modulating signal. So I'm just writing the modulating signal here. Modulating signal. It should be in single colon. This is the modulating signal. X label has to mention X label. There's no gap between X and label. It's time. So I will write time here. Commas. Inverted commas. Okay, and Y label. The graph should be complete with the axis, title, X label, Y label. It's amplitude here. Then you should define VC. Instantaneous value of the carrier is equal to the peak amplitude AC into sine of omega t. 2 pi fc. 2 pi fc is called omega into t. That's complete. Similarly, you have to write down subplot, plot, X label, Y label, titles, the same way. Subplot 412 means in the 4th row, 1 column, the second graph is my carrier wave. Plot T comma VC, title, carrier, signal, X label, time, Y label, amplitude. Now your modulated signal, the instantaneous value y is equal equal to 1 plus M into Vm into bracket closed not into Vc subplot 413 fourth row, 4 rows, 1 column and third graph. Subplot plot plot title modulated signal there's some error here. Let me try. Okay, modulated signal is this, that's right. Okay, I have titles wrong. Title modulated signal. Okay, alright, modulated signal and X label. Now you must be frequent with this. We have written third time here. X label, time, Y label, amplitude. So this is the first case. See, it has drawn 3 graphs in one slide here together. So I can see 3 columns here and 1 row and the third graph. That's why subplot is used. So just see, the carrier is there, modulating signal is 0, M is 0. So that's why my modulated output will be the same as my carrier. So this is the one case for M is equal to 0. Similarly, you can just change the modulating frequency and try for another one. Now we'll do the case 2. Case 2 is when you have M greater than 0 and less than 1. We're going to try this case here. This is the case 2. Case 2. Right? So we'll see this now. Second case. So in my second case, I have time t. I'm going to take t same from 0 to 1 second. From 0 to 1 second with an interval of 0.001. 0 to 1 second and interval of 0.001. So now here I'm going to take AM to be say around 2. And then my AC should be more than this. Let me take it as 6. So my M will be 1/3. So that fits in the case 2. My FC will be same. I'm going to keep my FC same. And and I'm going to vary my FM, modulating signal. So let my modulating signal FM be 5 Hz first, alright? And my M has to be specified that it should be AM by AC. It's defined. And now let's talk about the modulating signal, instantaneous value, which we had already done in the previous graph. Vm is equal to, I'll just straight away write AM sine 2 pi FMT. This is my instantaneous value of modulating signal, and so I'm going to plot it 1 1, plot between T and Vm. This command has been used. Title modulating signal, X label, time, Y label, this completes my modulating wave. Now my carrier is Vc is equal to carrier is Vc. So Vc is equal to AC. It's going to plot against the previous graphs, because I'm using 4 1 1 1, same plot. 2 pi FC T. So it's just plotting in their space. Subplot 412. Plot T comma DC. Title. This is going to be the modulate carrier wave. Sorry. Title carrier. X label. Time. Y label. Amplitude. Now my modulated signal Y is equal to 1 plus M Vm dot, this is into DC. Subplot 2 3. Plot between T, plot between x-axis and y-axis, T and Y. Title again, I want modulated signal, signal. Title modulated signal. Alright. So that completes with the X label is left. Time. Y label. Amplitude. Alright. So this completes. Now just see, it's beautifully done with modulating signal at the top. Carrier, you can see it's 10 times more, so you can see the squeezed up sine wave. And the last one is the modulated signal, and just look at the pattern. So this is the AM wave which we used for transmission of our modulating signal. Modulating signal is being transmitted through the carrier. It rides on the carrier, and the carrier wave, or you can say that carrier wave is being modified in terms of amplitude, and then it is being transmitted. So this is why the second case, and I like you to repeat this for take another modulating signal, say around 8 Hertz. This one was 5 Hertz. Take it for 8 Hertz and try out yourself. A third case that I'm going to try is for the critical. This is called the critical modulation as M. Case 3, as M is equal to 1 here. M is 1 here. So we are taking this case here. Everything is just saying T is between 0 to 1 second with 0.001 up to 1 second. We are plotting, and the EM I am taking 6, and VM I'm taking AC I'm taking 6 to make M1. SC same 100 Hertz. And FM is my say 5 Hertz. M I have to define, it's AM by AC. And similarly, you have to define VM, you have to define VC and your modulated signal Y. M is equal to AM by AC. Okay. Alright. So VM is equal to, let me just check if I can. Let's carry on. VM is equal to AM into sine 2 by FM T. Subplot 011. Plot must have come to know using X label, Y label, amplitude, and this is for VC now. It's equal to AC sine 2 pi f ct. Here also the title, but subplot 412, plot t comma bc. Alright. Okay. Plot. My keys are not working. Plot. Okay. T comma B C. Okay. Now let's label this title. That is carrier signal. Okay. Title. X label. X label. Time. Alright. Time. And Y label. The graph is incomplete without the labeling, so never mess the titles labels. Amplitude. Right, now we're done with this. And carrier wave is left now. No, carrier wave is done. Modulated is left. Y is equal to 1 plus M into Vm into Vc. Subplot 413. Plot t comma y. And then your titles. Modulated signal. Okay. And your X label. Modulated signal. Let me just look at the codes for case 3. Now this is case 3. where m is equal to 1 I'm taking. So T is this, AM and AC is 1, FC is 100 and this is 5. So I have corrected it though. M is equal to AM by AC. So VM is AM sine 2 pi FMT, and this is my so VM is plotted 2 pi FMT 411. VM is AM sine 2 pi FMT. Okay, that's right. And modulating signal. Then it's label and Y labels. VC is equal to A sine 2 pi FCT 412. Okay. Alright, plot. Title carrier. Okay. Next label. So now Y is equal to 1 plus M into VM into VC. Okay. 413. Plot TY. Title modulated signal. X label. Y label amplitude. This is kind of the same. Let me just take M to be M modulating signal. My FM to be 8. FM is 8, and my FC is say same 100. Let me take Y and repeat the Y is equal to 1 plus M into VM dot into VC. Alright. Yeah. So you need to just modify the frequency as well. At frequency 8, you are able to get this. This shows that it is this critical point, or just about to overmodulate if it goes just beyond M. M is beyond 1. So at M is equal to 1, so it just looks like as if it is the case of case 2. That's why I tried for different modulating frequency. This is the picture that we tend to get when M is greater than 1, and for M is equal to 1, it's more of same as the case 2. So try for different modulating frequency at f is equal to 8 or 9 hertz, higher. So we are done with the AM. We have covered 3 cases. First case when M was 0, so in there was no modulation, and the carrier is modulated wave is same as the carrier wave. Second case was when M is between 0 and 1. We get a wave like this one, like this. This is for the case 2. And then when M is 1 or greater than 1, it becomes like this. We get this kind of wave where the amplitudes vary, the bands vary. So try for different modulating wave for 8 hertz, 9 hertz, 10 hertz, and keeping frequency of carrier as 100 only. So you can find out the variation in AM for these 3 cases. And just play around by varying the FM. So we are done with amplitude modulation.